Welcome to Trimble Landfill Compactor Operators video short series. This short video series will be covering 1. Trimble Components Overview 2. Starting Trimble Earthworks 3. Using and customizing Trimble Earthworks. This is the first video in the series and we'll be covering what to look for and how it works. Generally speaking, landfill compactors only have a handful of technology components needed for proper operations. Knowing where they are and what function they perform can help greatly when troubleshooting potential issues in the field. Compactors will typically only have one GNSS receiver mounted as high as possible to avoid signal interference. Excessive buildup of dust, grime, or bird feces may negatively impact the receiver's performance. Keep this in mind during daily walkarounds. Trimble Earthworks will also come with an Android-based touchscreen display called a TD520 or TD540 mounted somewhere in the cab. You may be watching this video on such a display right now. The EC520 is the brains of the operation and typically mounted to the body behind an access panel. Think of the TD520 as a computer monitor and the EC520 as the computer. The SNM941 gateway device allows for internet connectivity. This is crucial for sending data to office-based software and receiving internet-based correction signals. This can be mounted outside or in the cab. The SNR machine radio is for picking up local radio-based corrections and will be mounted outside, oftentimes near the receiver. Trimble Earthworks will recognize what devices are connected. You may check on these devices in the System Status tile on the dashboard or in System Settings. Trimble help guides are built into the system. If you ever have a question about a specific screen you are on, just tap the eye icon in the upper right for more information. You will not be able to proceed to the operator view without green check marks on all items in the System Status screen. Tapping on the names will open their properties. Here I can see the GNSS receivers, model, firmware, mode, precisions, and number of satellites tracked. A mode of RTK, or real-time kinematics, means this receiver is communicating with the base station and receiving GNSS corrections. The type precisions also prove this to be true. A mode of autonomous would mean the receiver is not communicating with the base station. Noting the receiver's integrity within System Status will also help diagnose base station connection issues. This image represents a machine receiving data from satellites alone, also known as autonomous mode. Cell phones operate in autonomous mode and have accuracies ranging from 1 to 10 meters. This is mostly fine for navigating to a business or another town, but is not precise enough for machine control that requires centimeter-level accuracy. Satellite signals distort as they pass through Earth's atmosphere. This distortion and many other variables are what cause the poor accuracy. To solve for this, a base station is required. A base station that is established in a known location close to where the machine will be operating so as to see the same sky with the same atmospheric conditions as the machine's receiver. The base station receives the same distorted signals from the satellites, but uses its known location to correct for that distortion and send that corrected signal to the machine via radio or internet in real time. This is what we are referring to when we say corrections. It will always be necessary to receive base station corrections. You can easily check on your machine's radio, receiver, and gateway device, also known as a modem, within Earthworks itself. Additionally, the components themselves also have indicators in the form of LED lights. GNSS machine receivers have 3 lights representing 1. Power, 2. Data link, and 3. Satellite count. 1 is arguably the most important, as it will tell you if the receiver is getting power or not. The second light represents connection to the base station. If it is blinking, you are connected. If it is not, you are not. I should note that dual GNSS configurations, such as landfill dozers or graders, are a little different, where the right receiver should have a solid number 2 light, indicating connection to the left receiver. The left receiver is the primary receiver communicating with the base station, and should have the second light flashing to indicate thus. The SNM machine modem will be installed if your machine reports production data for density calculations back to the office, and/or if you are receiving your corrections via the internet. If both LED lights are blue, you're connected. If you see one blue and one green light, you are not pinging a network. Machine modems take several minutes to connect, but if the modem has been powered on for more than 10 minutes and is still not connecting, it may be worth power cycling the machine using the machine's kill switch specifically. SNR machine radios are for radio corrections, meaning the base station is broadcasting on a certain radio channel or frequency. If the LED light on the face of the radio is blinking, you are receiving corrections from the base station. If the light is solid, you are at least getting power. However, you are not receiving corrections. If this happens, it is often the base station has lost power, Or there may be an issue with the radio antenna on the machine radio or on the base station. This has been the Trimble Component Overview for Landfill Compactors. Please join us for the next video, where we will dive deeper into the Earthworks dashboard and menus. Trimble, transforming the way the world works.